This is chapter 10, problem number 2, the confidence interval part of it. We already did part 1, the hypothesis test, and in part 1, we found there was not enough evidence to say that the mean GPA of sophomores differed from the mean GPA of juniors. So now let's see what it looks like when we do a confidence interval for a similar situation. So here we're going to create a 95% confidence interval for the difference in the population mean for sophomores and juniors. So the mean of 1 minus the mean of 2. We're going to create an interval for that and see if it agrees with what we found in the hypothesis test. So remember here we're calling population 1 the sophomores, population 2 the juniors. We're doing a 95% interval, so that means the alpha for the confidence interval, right, is going to be 0.05 because it's a 95% interval. So now let's go ahead and proceed and fill out the equation here. So we'll go up just a little bit. So we have that, here's the equation from your equation sheet that we need to do the interval. We're going to need the two sample means. We have those. We have SP, which is the pooled sample standard deviation from part 1. We got that. If we didn't have it, we would have to calculate it, but we already have it. We have the sample size for population, sample size for population 1 and 2. So now we just need to get the T of alpha over 2, knowing that our the alpha is 0.5 in this case. So let's go ahead and get that before we fill in the rest of the equation. So now the T of alpha over 2 becomes the T of 0.05 divided by 2, which is the T of 0.025. And since it's a T value, we need to know the degree of freedom. We need to know which row to go to look it up in our chart. So we get the degree of freedom, which is the 2 sample sizes minus 2, which is, of course, 28. So you go to row 28, you look up T of 0.25, and you find out that it is 2.048. Alrighty, so we have everything now, so let's just go ahead and fill it in. So the two sample means, we've got 2.84 minus 2.98. So this is just from the summary information up here. Okay. We need to subtract those. Then we're going to add and subtract to that. We need the T of alpha over 2, so that's the 2.048. Then we need SP, okay, and that is from the previous problem we calculated it, 4.394, and then that's going to be multiplied by this quantity here, which is 1 over square root of 1 over 17 and 1 over 13, which when we do that, we end up with 0.3684. All right, so now we multiply these out, 4.394 and 2.048. So all of this here has to be multiplied together. So this is multiplied, okay. And then once we multiply that all out, it's going to be added and subtracted to negative 0.14. When you subtract these two, you get the negative 0.14. Okay, so when we multiply this out, we get negative 0.14 plus or minus. It ends up, when you multiply that all out, you get 0.332. Alrighty. So the actual interval, so you subtract 0.332 from 0.14, you get a negative 0.472. And on the other end, when you add it, you get a positive 0.192. Alrighty, so let's go ahead and see what that interval would look like. So now if I plot this interval on a number line, generic number line here, the lower end of the interval, negative 0.472 is down here, 0.472, positive 0.192 is here. What does this interval represent? This is where we're 95% confident that the difference in the two population means is going to be located, okay? So when we interpret it, the interpretation is going to say that we're 95% confident, right, that the difference in the two means is between negative 472 and positive 192. So that's how we would write that out. So I am 95% confident 95% confident that either the difference in the means, or you could say 1, remember 1 represents sophomores, so we're going to say that 1 compared to 2, that's how we're going to write the, interpret it here. So we're going to say I'm 95% confident that the mean GPA of sophomores, that's number 1. Population 1 is sophomores. So I'm 95% confident that the mean GPA of sophomores is between 0.472 less than and 0.192 more than the mean GPA of juniors. GPA of juniors. Or you could talk about it as a difference too. I just thought it was a little easier to understand this way. So I'm 95% confident the mean GPA of sophomores, so this is mu1, right, is between 0.472 less than, that's the negative part, and 0.192 more than, that's the positive part, the mean GPA of juniors, which is the mu2. And the last part of this is we want to, does this agree with the hypothesis test we did? Well, in the hypothesis test, we said we could not reject the null. In other words, we thought the mean of 1 might equal the mean of 2. There was not enough evidence to reject it. Well, when we look at this confidence interval, let's find out where 0 is. Since this interval goes from negative to a positive number on the other end, 0 is actually in the middle somewhere. It's like maybe around here somewhere. It's not exactly in the middle, but it's in there. 0, remember, is the spot where the mean of 1 equals the mean of 2. Because if two things are equal, when you subtract them, you're going to get 0. So this confidence interval agrees with what our hypothesis test said, because since 0 is in the interval, that means the mean of sophomores, or mu1, could equal the mean of juniors, since it's in the interval. Could equal the mean, sorry for the messiness, mean of juniors. It's hard to write on the bottom, or mu2. So since 0 is in the interval, the mean of sophomores, mu1, could equal the mean of juniors, mu2. So our confidence interval agrees with the hypothesis test that we just did. And that's that.